This is lesson 3 of unit 14. In this lesson we will talk about pH. Now pH is the numerical system we use with acids and bases, and technically, roughly speaking, it's a number system from 1 to about 14, but here they show it about to 12, that tells you how acidic or how basic a solution is. You may have heard of pH in terms of testing pool water or testing your fish tank for pH, and this tests how basic or how acidic the solution is. We'll reveal to you what these numbers mean and how they correspond to acidity. So here is the definition. The pH scale technically goes from 0 to 14, and it's a logarithmic scale. Now logarithmic means it's based on the power of 10, and the power here is what determines the number, or what the number is related or connected to. So a change on a logarithmic scale, a small change actually means a very big change. And if you know anything about earthquakes, earthquakes are actually measured on something called the Richter scale, and that scale is also logarithmic. A small change on the Richter scale is actually a big change in terms of earthquake size, and that's what we mean here. So before we get into the mathematics of it, here is the breakdown of pH. If you are at a pH of 7, that is neutral. You have a neutral solution. If the pH is below 7, this means less than 7, you are acidic. And if you have a pH higher than 7, you are basic. So pHs that are, we'll say, at the very bottom, near 0, are extremely acidic. So here you have your hydrochloric acid. The strong acid has a pH value of 0. And at 14, you have sodium hydroxide. If it's this is a little tough to see, this is 14, your strong base. Then in between there, you have weaker bases, and then you have weaker acids here. You'll notice that pure water, as well as blood, is roughly around 7. Blood is just a tad bit more than 7. But your baking soda was a base. We talked about baking soda being a base. Notice its pH is 9. Your bleach is definitely basic. And your cleaners, your oven cleaner, for example, is very basic. Whereas some of your fruits and vegetables, like tomatoes, are acidic. Here you have lemon juice, which is acidic, vinegar and soda, and so forth. So this is kind of the breakdown. Now these numbers, 14, 13, 12, 11, if you take a look on the left side here, they're corresponding to a power. Notice the pH of 4 corresponds to a power of -4. pH of 12 corresponds to a power of -12. And that's where the pH comes. It comes from the power of 10. So here is the mathematical definition of pH then. pH means the power of hydrogen. And what we mean by the power is literally the power in the 10 to the power. That's what we're referring to. And it measures the molarity of H plus in solution. So what happens is the higher the molarity of H plus, the lower the pH. This is an inverse relationship. The more acidic you are, the lower the pH. So the more hydrogen ion you produce, because acids produce hydrogen ion, the more acidic you are. Mathematically, here is the equation. pH equals negative log of H plus. Now, if you don't know how to work with logs, then you just have to plug this into the calculator. There's a button on your calculator called the log button. Find it, and all you have to do. But if you want to understand a little more deeply what this does, is the log is the inverse operation of the power. So what it does, it pulls out the power, essentially. So if you have a number like 0.0045, and you apply a log to it, what you're saying is, what would the power be on 10 to give you this number? That is all we'll say about the mathematical side of logarithms. Let's go ahead and try a few examples. So here it says, what is the pH if your hydrogen ion concentration is 5.20 times 10 to the -5th? So what you have to do, essentially, is apply our equation. pH is negative log of 5.20 times 10 to the -5th. Now you can rewrite 10 to the -5th as 4 zeros, 5, 2. Or you could just write it this way in your calculator and go ahead and plug it in. Find the log button. Now you have to put the negative in front of it, or if it depends on the calculator, you may have to put a negative after. So let's go ahead and do 5.20 times 10 to the negative fifth. Take the log of that and take the negative. You should get yourself an answer that looks like this. 4.28 is the pH. Now, what are the units? There actually are no units. Unitless. This is a rare occurrence in chemistry. Usually we do not let you get away without putting units, but this number is unitless because we're taking a look at the power. So the power essentially 10 to the essentially to this power. This was the power that created this small number, and this roughly tells you how much hydrogen, the power of hydrogen in solution. Let's try this next one. Here we say, what is the pH of 0.20 moles of nitric acid in 4 liters of solution? So in this case, we have to first solve for the molarity, because remember, pH is the negative log of the brackets. This means molarity, which is moles per liter. So we'll have to first solve for moles per liter for molarity. So molarity in this case is 0.20 over 4.0, because it's moles divided by liters. And if you divide these two numbers by themselves, you should get yourself 0.05. And then we can plug this number into our pH. Our pH will end up being negative log of 0.05, which is, go ahead and plug this into your calculator. You should get 1.3 for the pH. Again, no units. So the question is this example more or less acidic than example 1? And this is more acidic because the pH is lower. So this would be more of a strong acid that we are dealing with here. We're going to do the same thing in the case of bases now. So go ahead and let's try this example here. Well, first of all, before we do the example, we'll ask the question, what if we have a basic solution instead of an acidic solution? Remember, bases produce hydroxide ion. How do we get the pH? Well, let's define the same thing we defined for acids, but now for bases. So POH is the power of hydroxide ion. Same exact idea. The equation is set up exactly the same, except here you have hydroxide ion. Now, to get to the pH, it's rare that somebody asks you for the POH. The POH is just kind of an intermediate step to get to the pH. And then to get to the pH, we use this equation. pH plus POH equals 14. So we're saying acid plus base total is 14. That's the total of the two pHs. So to get the pH, we'll subtract POH from 14. If this sounds confusing, let's do an example problem or two, and you'll see that it's actually the same thing we've been doing plus one small extra step. So here is example 3, and the example asks, what's the pH if the hydroxide ion concentration is 0.039? So what we could get first, let's get the POH, which is simply the negative log of our OH minus concentration, which is this number, 0.039. Go ahead and plug this into your calculator and tell me what you get. You should get yourself 1.4. And really 2 sig figs, so that will work. 1.4. This is the POH. And now, to get the pH, it's as simple as doing 14 minus 1.4. Because the two, POH and pH, add up to 14, so you would subtract 14 from that, or that from 14 rather. And you should get yourself 12.6. And here is the pH, 12.6. Again, no units. So we did the same thing, except this extra step was required. All right. How about we take a look at this example? What is the pH of a solution containing 1.2 grams of potassium hydroxide and 16.1 liters? So why don't we do the, let's get the molarity first, because remember, POH is what we want to find first. since we have a base. This is a base. So that's how we know we have to get the pOH first. And you can see that there's an OH in the compound. So we'll do the negative log of the brackets, and again, brackets is molarity, which is moles per liter. So now to get moles, we have to convert from grams to moles. So we got 1.2 grams of KOH. We'll put grams on the bottom, a mole on top. Go ahead and add up KOH. Potassium should be 39.10. Plus hydrogen should be 1.01. Plus oxygen should be 16 for a total of 5611. So we got 1.2 over 5611. Go ahead and do this in your calculator for a total of 0.0214. And I'll do 21, how about 39? Let's keep a few more sig figs until the very end. So this is how many moles we have. Now molarity would be 0.02139 over our liters, and we have 16.1 liters, which gives us 0.001328. This is the molarity now of hydroxide ion. And now we can get the pOH, which is the negative log of that. So go ahead and plug this into your calculator. Take the negative log of this number, and when you do, you should get yourself 2.877. Now this is not the pH yet. We have to now subtract from 14, and if it's going to get a bit tight, let me do, we'll do it at the edge here. So pH is 14 minus 2.877, which is 11.1. And this is our final answer. I know that was a bit involved, but the idea is pretty simple. The new thing is pOH, which is the negative log of the concentration of the base. We have to figure out the concentration by doing grams divided by, to get to moles, grams to moles, divided by liters. We plugged it in, subtracting from 14. So we'll practice this a little more, but this completes for us video 3 of Unit 14.